The last topic in section 1.8 is how to solve a radical equation. A radical equation is an equation that has at least one radical expression containing a variable. We're going to look at a procedure table for how to solve a radical equation, but again, it's often better to look at some examples, which we'll do as well. Step 1 says to begin by isolating the radical expression on one side of the equation. So by radical, remember that we are talking about a square root or a cubed root. Okay, so something of that symbol. So we want that part of the equation to be by itself. Step 2 says to raise both sides of the equation by the power necessary to undo the isolated radical. So, for example, if we have a third root in our problem, we will raise both sides to the third power. If we have a fourth root, we'll raise both sides to the fourth power, and so forth. Step 3 says, if any radical expression remains, we're going to simplify the equation if possible, and then repeat steps 1 and 2 until we don't have any more radicals. Step 4 says to check your solutions in the original equation, and this is important because often we will have solutions that are not truly solutions, and those need to be discarded. Okay, so let's begin with a problem that looks like the square root of 1 minus x, and then we have minus 1 is equal to x. So remember that step 1 is to isolate the radical expression. So that means to get that square root by itself on one side. So in order to do that, I need to add this 1 to both sides of the expression. And so that's going to give me the square root of 1 minus x on the left and x plus 1 on the right. Now remember, step 2 says raise both sides of the equation to the power necessary to undo the radical. So in our example, we have a square root, so we are going to raise both sides to the second power. Now on the left-hand side, that's easy because when you square root and then you square, they cancel each other out and you're left with 1 minus x. On the right-hand side, you have x plus 1 times x plus 1, which you are going to need to FOIL out. So you might somewhere off to the side jot that down so you can see it and then FOIL it out. So first times first is going to give you x squared. Outside gives you 1x, inside gives you 1x, and last gives you 1. So we have 1 minus x is equal to x squared plus 2x, combining those middle terms, plus 1. Now the next thing that we want to do, since we see that it's quadratic, because we see that the highest power is 2, is that we want to get it ready to factor, which means we want everything on one side. So I'm going to start by adding an x to both sides. And so that's going to give me 1 is equal to x squared plus 3x plus 1. And then I'm going to subtract the 1 from both sides, which is going to give me 0 is equal to x squared plus 3x. Now, for quadratic, we want to try to factor if possible. And so if I'm looking at this in terms of factoring, it doesn't have the 3 terms, so I'm not thinking 2 sets of parentheses. Instead, I'm going to look and see if there's something common that I can pull out of both terms, which I see that I can pull out an x. So if I take an x out of x squared, that's going to leave me an x. I take an x out of 3x, that's going to leave me a 3. So as you set each of those solutions equal to 0, you're going to have as your potential answers x is equal to 0 and x is equal to negative 3. Now, we do need to check these answers to make sure that they make sense in our original problem. So let's go back over here and let's plug them in and be sure. So if I plug a 0 in for the x, so that's going to be putting a 0 in those two spots. we're going to have the square root of 1 minus 0 is 1, minus 1 is equal to 0. The square root of 1 is 1. Okay, so that one looks good. 1 minus 1 is equal to 0, so I think we're okay with that one. All right, then we're going to plug in a negative 3 in for the x. And look at that one. So underneath the radical, we have 1 minus a negative 3, which is 4. Minus 1 equals negative 3. The square root of 4 is 2. Minus 1. Okay, so 2 minus 1 does not equal negative 3. And so this is not a solution. The only answer would be x is equal to 0. All right, so let's move on to part B. Part B, we have two radicals. So we have the square root of x plus 1 plus the square root of x plus 2 is equal to 1. And our directions say to isolate one of the radicals. So I am going to keep the x plus 1 radical on the left, and I'm going to subtract off the square root of x plus 2. And so that gives me the square root of x plus 1 is equal to 1 minus the square root of x plus 2. All right, so following our procedure, we now raise both sides to a power to get rid of the radical. And so we know that the square root is going to require us raising both sides to the second power. And again, what's happening on the left is fairly easy. We have a square root and a square, and they cancel each other out, which leaves us an x plus 1. What's happening on the right is more complicated. We have a 1 minus a square root of x plus 2, and it's squared. So that really means that we're multiplying this term by itself 2 times. So a common mistake for students to make is that they just square both of these terms inside. You can't do that because of the subtraction. You have to do the FOIL method on it. So let's multiply it out. First times first, 1 times 1 is 1. Outside is going to give me a 1 times this negative square root. So we've got a negative square root of x plus 2. On the inside, we have a 1 times that negative square root. And the last, we have a negative and a negative, which is going to make a positive. We have a square root of x plus 2 times a square root of x plus 2. And so what happens there is that that square root kind of comes off, all right, because it's almost like you have a square root of x plus 2 and it's squared because you have 2 of them. So that square root is going to disappear as we simplify. All right, so I have x plus 1 is equal to 1 minus, I have 2 of these middle terms, so 2 on the square root of x plus 2. And again, the square root and the square on the last term is going to cancel, and we're going to have plus x plus 2. Now, the next step is to isolate the remaining radical. Remember that our procedure said if you had more than one radical, you would need to start over with the steps until you eliminate every radical in the problem. Okay, so let's see what we can do here. I'm going to start by, tell you what, let's start by combining this 1 and this 2 on the right-hand side. So I have x plus 1 is equal to 1 plus 2 is 3, minus 2 on the square root of x plus 2 plus x. All right, so I am going to first subtract the 3 from both sides. That's going to give me x minus 2 is equal to negative 2 on the square root of x plus 2 plus x. Then I'm going to subtract the x. And notice that it's going to fall out on both sides, which makes things a little bit easier for me to deal with. I'm going to come up here. That's going to leave me negative 2 is equal to negative 2 on the square root of x plus 2. Now, remember your goal is to get the radical by itself. So I still need to deal with this -2. So I'm going to divide it out by -2. On the right, we're going to have, on the left, we're going to have -2 over -2. That's 1. They'll cancel on the right, leaving me the square root of x plus 2. Okay, so now we're ready again to raise both sides to a power to get rid of the radical. And so that power again would be the second power, which is going to give me 1 is equal to x plus 2. And solving for x, we're going to get x is equal to -1. All right, we need to check that solution to be sure that it works. All right, so I'm going to do that real quick to make sure. We're going to plug a -1 in for the x's. I'm just going to come up here and put it right like that. And let's look at what we've got. So on the first radical, we have the square root of -1 plus +1. That's going to become 0, so that's not going to be an issue. Then we have the square root of -1 plus 2. That's going to be the square root of 1 is equal to 1. And so I can see that that does check and is correct. Okay, so part C, we're seeing a fourth root. So we have the fourth root of x squared plus 8x plus 7, and then we have a -2 is equal to 0. So again, first step is to isolate that radical, and we do that by adding this 2 to both sides. So we have the fourth root of x squared plus 8x plus 7 is equal to 2. Second step is to raise both sides to a power to eliminate the root. So if we've got a fourth root, we're going to raise both sides to the fourth power. That's going to cause the radical to come off on the left, and so we just have x squared plus 8x plus 7. 2 to the fourth is 16. Now the radical is gone. The highest power is a 2, which makes it quadratic, which means I'm thinking about factoring. If I'm going to factor, I need everything on one side. So I'm going to subtract the 16 off. So that gives me x squared plus 8x minus 9 is equal to 0. Let's see if this factors. For the x squared, we'll need x and x. For the 9, we can do 9 and 1 or 3 and 3. But remember, you need it to combine to give you 8. So 9 and 1 would subtract to make 8. You need the positive on the 8. So you need the bigger one positive and the smaller one negative. And so potential solutions there would be -9 and +1. And again, we do need to check these solutions. So if we put -9 in for the x, we want to make sure that we get 0. So we have the fourth root of -9 squared would be 81. 8 times -9 would be -72 plus 7 minus 2. So we have the fourth root. 81 plus 72 is going to be 9. 9 plus 7 is going to be 16. So the fourth root of 16 we know is 2. 2 times 2 times 2 times 2 is 16. Minus 2 is equal to 0. So we know that the 9 looks pretty good. Okay, 9 works perfect. All right, let's try the 1. So I'm going to plug the 1 in for the x. So I have the fourth root of 1 squared plus 8 times 1 plus 7 minus 2. The fourth root of 1 squared is 1 plus 8 plus 7. That's going to be the fourth root of 16 again. Fourth root of 16 is 2. 2 minus 2 is 0. And so both of those answers check, and both of the numbers are solutions to our problem. Okay, so the other type of rational equation that we're going to deal with is a problem where we have an exponent that is a rational number. So our rule set, or our definition says that if we have a to the m over n, where m and n are natural numbers with n not equal to 0, then we can rewrite this, and we've talked a little bit about this already. A to the m over n is the same thing as the nth root of a to the m, all right, which is the same thing as the nth root of a raised to the m power. All right, so what this means to us is that if we have a problem like x to the 2/3, that is the same thing as, x squared and the cubed root of that. Or we could write it as the cubed root of x raised to the second power. Okay? All right, so let's look at a couple of examples there. All right, so two examples that we're going to deal with. The first one is x to the 2/3 minus 9 is equal to 0. All right, and so we're going to follow our same procedure in that we want to isolate the radical. So we're going to add the 9 to both sides. So we're going to have x to the 2/3 is equal to 9. Now I'm going to take that x to the 2/3 and use the rule that we just saw. Okay, and so we said x to the 2/3 was the same thing as the cubed root of x squared. So let's write it that way instead. So the cubed root of x squared is equal to 9. Now, we know how to deal with this cubed root because we talked about it in the last couple of examples. If it's a cubed root, we're going to raise both sides to what power? The third. So the cubed root of the third power is just going to give me x squared. And 9 to the third is going to give me 729. All right, and then how do we deal with that answer? X squared is equal to 729. We need to figure out how to deal with that. We're going to take the square root of both sides. And so that's going to give me x is equal to, now don't forget your plus or minus, the square root of 729 is going to be 27. All right, and again, you need to check your answers to be sure that your answers are both solutions. So you do have two solutions. X is equal to 27, x is equal to negative 27. In the interest of time, I'm not going to plug them back in right now, but you would want to, on your calculator, plug in the 27, plug in the negative 27, and make sure that both are solutions. Okay, let's move on to our second example. We have 32x squared minus 32x plus 17, and that is all raised to the 1/4 power. And it's equal to 3. So we're going to take that problem, that 1/4 power, and let's take it back into a radical form. So remember that a 1/4 power, according to our rule, would be the same thing as the 4th root of x to the 1st, okay, or the 4th root of x. So I am going to write it this way. I'm going to write it as the 4th root of 32x squared minus 32x plus 17 is equal to 3. And now we have a radical that has been isolated. How do we solve it? We raise both sides to the 4th power. If we're dealing with a 4th root, we're going to raise to the 4th power, which is going to cause the radical to come off on the left. And 3 to the 4th, 3 times 3 times 3 times 3 is 81. Now again, as I'm looking at this, I'm seeing that it's now quadratic because the highest power is 2. I want to be able to factor it if possible. And in order to factor, I need everything on one side. So I'll subtract the 81. That's going to give me 32x squared minus 32x minus 64 is equal to 0. All right, so now as I look at this, I think about factoring it. Remember that the easiest thing to do with factoring is if there's anything common to all of your terms, you would want to pull that out first. So I definitely could pull out a 32. So 32 out of 32x squared leaves me an x squared. 32 out of 32x leaves me an x. 32 out of 64 leaves me 2. And so my hope is that now what I'm left with will factor fairly easily. We know it has to be x and x for the x squared. For the 2, it's got to be 2 and 1. We want our middle term to be negative, which means the bigger one needs to be a subtraction. And so our solutions would look like 2 and negative 1. And again, you would want to plug in both of those answers into the original problem to be sure that they are truly solutions to our problem.